Greetings everyone, I am BRILLANTE from 2IT-A and I'm going to discuss the head class. So in our robot program, the head class is responsible for representing the robot's head component, which plays a key role in both sensor functionality and visual characteristics. So we have the attributes, which are the private string eye color and private string sensor type. So the eye color stores the visual appearance of the robot's eyes. These could represent a static design or even visual output. For the private string sensor type, so this defines what kind of sensing capability the robot's head has, such as infrared sensors. So this allows us to simulate realistic detection behavior. Now for the constructor, we have the public head string eye color string sensor type. So this constructor allows for customizable head creation. When a robot is assembled, it passes specific values for eye color and sensor type. So this lets the robot head be tailored to either a default or user-defined configuration. So next is the public void active. So this method simulates the head powering up and making its sensors operational. It brings up the head's configuration details, which shows feedback that the head component is active and functioning correctly. Next is the method scan area. So this method simulates the robot scanning its environment for threats. It outputs a mock scan result, including quick coordinates and a sample threat ID, giving a sense of how a robot could behave in a combat or surveillance scenario. So that's it.
So greetings, I'm FAJARDO and today I am assigned to explain the ARMS.java class. So let's start. So this class is basically representing a pair of arms that has a certain strength level. This class lets us activate the arms or make them punch and shows that information using print statements. So to further explain, let's do a line-by-line explanation. So for this line, public class arms, let's create the class name arms. It's public so other parts of the program can use it. Next, for this one, this stores the strength level of the arms. It's private, meaning only this class can access or change it directly. Next, for this part, this is the constructor of the class. When you create an arms object, you give it a strength level. So that strength level equals strength level refers to the variable in the class, and we're setting it to whatever value gets passed in. So next, public void activate. So this is the activate method. So this method activates the arms and prints out the strength level. Next, public void punch. So this is the punch method, and this one simulates a punch and also prints the strength level. So basically, this whole class just stores a strength value and lets you do two things, which is activate the arms and punch, both using the strength level. So that is all for ARMS.java. Thank you.
Greetings everyone. My name is MEJIA. So today I'm assigned to discuss the torso.java class. So let's start. The purpose of torso class is to represent the central body component of a robot, and it will be responsible for housing the robot power source and distributing energy to all other parts. And the attribute of it is the private string power source. Here, this is a string describing the type of energy core, which is this will be used to power to the robot. And next is the constructor public torso string power source, which is this will initialize the torso object with a specific power source. And lastly, the method, this will be simulate the powering up of the torso, and this will print the message when indicating that torso is active and energy is being distributed to all robot parts. And I think that's all, and thank you.
Greetings, my name is AMANDY and I will discuss the public class legs. So for the part of the class is the private mobility level. This is a private variable called mobility level, and it will store how fast the legs are. Next is the constructor, which is the public legs int mobility level. This dot mobility level equal mobility level. This is a constructor that create a new leg of object. It will take a one input mobility level. Next is the public void activate. This is a method. When you call activate, it prints a message showing the legs are on and display their mobility level. Next is the public void move. When you call the move, it will show that the legs are moving and also uses the mobility level in the message. And that's all for my part.
So this is a class weapon. So sa una is nag-declare tayo ng class na pangalan is weapon. And nag-initialize din tayo dito ng mga instance variables natin na weapon type na natanggap ng string and power level na natanggap ng int. So ito ay private. So hindi siya accessible sa ibang class. So ayun. So may constructor tayo dito na ayun tinawag natin. yung weapon type and power level. So dito, sa constructor na to is na-create tayo ng object sa loob ng class. So yung mga this.weapon or this.power level, no, ay yung mga parameter. So dun pinapasa. So dito makikita natin na may mga methods tayo dito na activate. So yung activate, this method prints a message. So ito yung print natin na ini-indicate na ito na that weapon system is turned on and its type and the power level. So dito natin, activate. So i-print niya to. So yung type, yung weapon type. So yung and then also yung power level. So ayun. So meron din tayo ditong method na attack. So dito sinisimulate niya yung attack na nagpiprint ng message. So yung firing, tapos kukunin niya yung weapon type and yung power level. So this is the class of weapon.
Greetings everyone, I'm FRISCO and I'm here to discuss the robot class. So the robot class has fields that define the robot's properties such as name and model number. Additionally, it contains references to its components, which is the head, torso, arms, legs, and weapon. These parts are set later when the robot is assembled. The constructor takes the robot's name and model number as parameters and initializes these values. However, the physical components like the head and torso aren't initialized at this point. The assemble method will handle that later. The assemble method takes various parts and assigns them to the corresponding fields in the robot class. After assigning these components, it prints a message confirming that the robot has been successfully assembled. The power-up method simulates the process of activating the robot. It calls activate method of each component to power up those parts. After all components are activated, it prints a message saying that the robot is now fully operational. The combat method simulates the robot engaging in battle. It first prints a message indicating the start of combat, then calls the punch method from the arm class and the attack method from the weapon class. It concludes by printing a message saying the robot successfully eliminated a threat. The move method allows the robot to move. It calls the move method from the legs component, enabling the robot to move based on the legs capabilities. The scan area method calls the scan area method of the head component. This simulates the robot scanning its environment for threats and detecting any possible danger. So the robot can be powered up, engage in combat, move, and scan its environment, with each action performed by invoking methods on the relevant components.
Greetings everyone, my name is Rosales and I'll be discussing the program's robot assembly line class and the main class, which I will be discussing also the whole demonstration of the program itself. So starting with the robot assembly line class, it consists of constructors that ask values from the main method in the main class and then transfers it into the constructors inside of it, which are basically the robot and its parts. These constructors have a return value, which allows the program to display and show the robot assembly, scanning, and combat. The robot assembly line class features constructor overloading since it has two constructors of the same name. Build the robot but asked for different parameters. The first one asks for the name, model number, eye color, power source, and the weapon of choice, allowing for the user a more customizable robot assembly. While the second constructor only asks for the name and the model number, which allows for a default robot assembly. All the parameters are asked from the main method, which is inside the main class. So basically, in here, we are declaring the scanner and, of course, the robot assembly line object. We will be also declaring other variables here, such as the robot object, the robot type, which will be discussed later, along with the robot start variable. And here we have these variables that are going to be used for the robot assembly line constructors. So first, the program will ask if the user wants a default assembly or a customized assembly. So the user input here will be processed in the if-else-if condition statements, wherein 0, which is meaning wherein 0 means a default assembly and 1 is a customized assembly, and any other value than 0 and 1 will result in an invalid option message. So let's first pick 0, and as you can see, it already did the work for us, wherein it calls on the constructor that only asks for two parameters, namely the model number and the name. And with that, it already assigns a default values to the parts and allows us to see the whole process. As you can see, the assembly and the activation of its parts, the scanning of the environment, and the combat itself. And now, when we pick the number 1, as you can see, it allows us for customizing the robot. So let's say this is the name of the robot and the model number. And the robot's eye color, let's say brown or blue. How about the power source? Let's just say and then its weapon of choice. And once we enter, we are greeted with the whole process itself. And as you can see, the values that we have entered is reflected or shown in the process itself. The model number, the name, the power source, the eye color, and the weapon of choice. Now let's move forward with another part of our program wherein we will type any other values besides 0 and 1. So let's say 2. As you can see, it results in an invalid option message and completely halts or terminates the program with the message robot within process stopped due to invalid option. So what does this second if-else structure do? Basically, this second if-else structure sees if the robot start variable is in a true or false state. So basically, if it's in the true state, it starts up all the assembly process and of course its other activities. However, if it's in false, it does not proceed with the robot activities. Okay, so the robot start variable is initialized as false. However, it can be changed into true once the program is done calling on the constructor of the robot assembly line class. And once it's done, it changes the robot start variable into true and proceeds with the whole robot activity, which includes the power up, the scanning of the area, the move, and of course the compact. And this includes the assembly of the parts in the beginning. So that is all for our program. Thank you for listening.